Hello everyone, my name is Vishwesh and I am from SSN College of Engineering and my teammates are Kirtana, Shreyasi, Poojashri. We are going to present on the topic microcontroller based washing machine simulation using PixSimLab. This project simulates a washing machine using PixSimLab which enables the development of embedded control logic in a virtual environment. User can interact with the system using simulated switches and observe responses on the CLCD display and monitor the complete washing cycle from start to completion. This virtual environment replicates a key operations such as program selection, water level setting, and functional execution. And the purpose of this project is to simulate the real-world operation of washing machine in a PIC microcontroller, which can be simulated using PixSimLab software. This software provides a virtual platform for understanding washing machine components, cycles, and control logic. It also enhances skills in embedded system programming, user interface design, and system simulation without the actual need of physical hardware. This is the board that we are using for washing machine simulation. Here we are using PIC16 F877A microprocessor, which is simulated using PixSimLab software. In this virtual environment, we have a keypad with multiple keys. This is switch 1, switch 2, switch 3, switch 4, switch 5, switch 6 and switch 7. These are the keys we will be using for simulating the washing machine program. And the functionalities and the program selection will be done using the CLCD display, which can be viewed to which can be used to view the functionality. This motor is used to replicate the washing of clothes which is done in the real world washing machine, and this buzzer is used to indicate whether the door is open or closed. When the door is open, this buzzer will beep. And this is the entire block diagram of washing machine functionality which is integrated in the PIC microcontroller. Here we have used switch 5 for powering on, and switch 6 is used for pause and stop, and switch 4 is used to navigate within different features such as water level selection or washing program selection, and switch 1 is used to check the door status. And the display CLCD is used to navigate from one feature to another feature, and motor which replicates the washing of clothes, and buzzer used to check the door status. To view the functionality of washing machine, we need CLCD display which simulates every stage of washing machine. The first stage is power on. When the board is reset, initially after loading the program, when the board is reset, we will see the first screen showing press key 5 to power on washing machine. Here input switch 5 is used. Once the switch 5 is pressed, the washing machine is turned on and it shows powering on washing machine. Once this screen is completed, it shows the washing program. We have multiple washing programs such as daily, heavy, dedicated, white, stain wash, etc. This can be navigated using switch 4. Pressing the switch 4 will scroll between the available options, and this asterisk shows the current option that is being selected. Long pressing switch 4 will confirm the selection and move to the next screen. The next screen shows the water level that is needed for the current washing machine functionality. We have multiple washing machine water levels such as auto, low, medium, high and max. Same as before, we will be using switch 4 to scroll between the options, and long pressing the switch 4 will confirm the selection and move to the next screen. In the next screen, we will use switch 5 and switch 6 for the input. Pressing switch 5 will start the washing machine, and pressing switch 6 will stop it. Once the switch 5 is pressed, we'll get to see the washing program that is being selected and the time taken for it to complete the washing. Pressing switch 5 will start and the timer will start to reduce, and pressing switch 6 will stop the timer and it will pause. Uh, while the washing machine is running, if the switch 1 is pressed, it means the door status is now open. When if the door is open in a washing machine, the buzzer will beep showing a sign door is open, please close. Once the timer reaches 0, which means the washing machine has washed its clothes and its functionality is finished. Hence, it shows the last screen showing that program completed, remove clothes. These are the steps. These are the screens that will be shown in the PIC microcontroller, which is virtually simulated using PIC SimLab.
Hello all, I am Keetana GS from SSN College of Engineering. So basically what is an embedded system? An embedded system is a microcontroller or a microprocessor based computer system that is designed to perform specific predefined tasks within a larger mechanical or an electrical system. So from the name itself we can understand that it is embedded as a part of a complete device which includes both hardware as well as software, and it is optimized to provide real-time performance, reliability and efficiency. And unlike other general purpose computers that are designed to perform a wide range of tasks, these embedded systems are very task specific and are often resource constrained and typically operate within minimal user intervention. So these embedded systems are very commonly found in devices such as washing machines, where they manage very specific tasks. So there are generally two types of embedded systems. So one is the based on the requirement of functionalities and performance, and another is based on ability of the microcontrollers. So coming to real-time ES, which are systems that responds to inputs within a strict time deadline. And second type is standalone ES, which perform dedicated functions independently without needing a host system. And third one is mobile ES, which is compact, portable systems that are often powered by batteries. And the last one is network ES, which is connected to a network for communication and control. And we have three subtypes under the second type. So the first one is small scale ES, which uses an 8-bit or a 16-bit microcontroller that is designed for very simple and day-to-day tasks. And next we have the sophisticated ES, which uses very powerful processors for complex functions along with OS support as well. And third one is the medium ES, which uses 16-bit or a 32-bit microcontroller with moderate complexity. And there are two broad classifications in data types in C. One is the primitive and another one is the derived. So under primitive we have four subtypes. So the first one is int, which is basically used to store the whole numbers without any decimals. And the second one is char, which is used to store a single character using just one byte. And the third one is float, which stores decimal numbers with a single precision. And double stores the decimal numbers with double precisions. And coming to the derived one, we have 5 subtypes, under which array is a collection of elements of the same type stored in contiguous memory. And structure is a group of variables of different data types under a single name. And in union, we have structures that are similar but share memory among the members. And in enum, they are used to assign names to integral constants, which are used to improve the readability. And finally, we have the pointers, which stores the memory address of another variable. And coming to the operators in C, we have 7 subtypes, under which the first one is a unary operator, which works on a single operand to increment or decrement its value. And next we have the arithmetic operator, which performs basic math operations like addition, subtraction, multiplication, division and modulo. And next is the rational operator, which compares the values and returns either true or false. And next we have the logical operator, which combines multiple conditions like and, or, not. And next one is the bitwise operator, which operates at bit level for binary data. And the next one is the assignment operator, which is used to assign or update the value of a variable. And finally, we have the ternary operator, which is also known as the conditional operator, that is a shortcut for if else conditions in a single line. So apart from this unary and the ternary operator, all other operators are said to be binary operators in general. So coming to the conditional statements in C, we have 6 types. So the first one is if, which executes a block of code only if the condition is true. So if the condition is false, nothing will be printed. And coming to the if else blocks, which executes one block if the condition is true and another if it is false. And we have if else if, which checks multiple conditions in sequence until one becomes true. And we have nested if, which contains an if or if else block written inside another if or else block. And we have the ternary one, which is a shorthand way to write simple if else statements. And finally, we have the switch, which selects one of many code blocks to execute based on a variable's value. So coming to the software requirements of this particular project, so the first one is MPLab X IDE, which is an integrated development environment by the microchip. So it is used to write, compile and debug the code for PIC microcontrollers. And the second one is MPLab X C8 compiler, which is a C compiler for 8-bit PIC microcontrollers. And it converts C code into machine code. It is optimized for its performance and code size. So the third one is PixemLab, which is an open source simulator for PIC microcontrollers, and it allows testing embedded code without the requirement of any hardware. And it also supports MPLab compiled.hex files and virtual hardware interaction. Thank you.
Hello everyone, this is Pooja Shri, currently pursuing my final year in Electrical and Electronics Engineering from SSN College of Engineering. So my friends might have explained about the idea of the project, and now I'll explain about the usage of microcontroller in this. So for our project, we have chosen PIC16F877A microcontroller, which you can see the picture here. So while talking about the microcontroller, I'll explain the components of it now. So first of all, when you talk about microcontroller, there is two important things. One is once we build the code for a microcontroller, there is two important things, that is its ability to store the necessary information. For that we use two types of memory: volatile memory and non-volatile memory. So here non-volatile memory is there to store the data even when the power is off from a source, while volatile memory is valid only for that particular period. So from here what we can say is, generally non-volatile memory is used for cases where a memory has to be stored, and cases memory has to be stored, and cases where the controller should work even in the absence of power. So then we have CPU, which is the any microcontroller must have a processor in it. Processor. That's why we are using CPU in this. Then followed by so here the flash memory, SRAM, EEPROM. All these are types of memories to store the data. Followed by the input output ports. So we have 5 different ports. So all these ports are used to store pass input informations, or to get the outputs. So for that cases we use input output ports. Then followed by timers. So we use timers in cases where we have to specify like this function has to work for this particular time, and after this it has to do this job. So like generally explaining a particular time for explaining a function in a particular time, so in that cases we use timers. So I'll explain about timers in detail a little later. And then analog to digital control converter. So the in nature we generally have all the datas are in general are analog. So in order to get a defined output, we use an analog to digital converter, which is very very important. So to communicate between two systems, we need we need a communication, and this communication is done using USART. Like the transfer of data and receiving of data is done using USART, which is a serial communication. And then I2C and SPI. Thing which differentiates USART with I2C is I2C is very advanced compared to the USART, and USART is a serial communication. Then followed by CCP modules. These modules are used in function where the function involves using PWM sinusoidal operations, PWM waves, comparing the values. In all these cases, we use CCP modules. And then another important thing is interrupt. So I'll talk about interrupt in the next part. So and then oscillator circuit to control the clock, and then time watchdog timer, and circuit serial ports, the serial programming. So these are the major components of microcontroller. You can see the structure of this. Now I'll explain about the timer. So as I said, for for any embedded system, we have to display like this part or this task there to perform this particular task for this much of time. So to define a particular to define a particular task or to set a time, for that case we use a timer. So generally in the above microcontroller, that is PIC 16F877A, in this microcontroller we use three types of timers: timer 0, timer 1, and timer 2. So in timer 1 is quite different from timer 0 and timer 2. It's because of the bit size, which is 16. uh, so since it is a 16 bit, my 16 bit timer, it is more precise when compared to timer 0 and timer 1. And then next is interrupt. So why do we need interrupt? So interrupt is used in cases when you have to give a particular priority to a particular when you have supposed to give higher priority to a particular function. For example, let us assume that we are performing a particular set of, for a few set of tasks. In one such case, or in one emergency case, you are supposed to pause the above task and come do a particular task in that another different task in that situation. In that case, we use interrupt. So in simple words, temporary interrupt is used in cases to temporarily stop a particular event and then perform another important event which has higher priority than the general event which was being executed. In that case, interrupts are used. So these interrupts can be external interrupts, peripheral interrupts, port change interrupts, and timer overflow. So external interrupt is like the interrupt given through the RB0 pins. Peripheral interrupts are from peripheral interrupts are from timers, USARTs, these communication devices, and ADCs. And then this port change interrupt, this is the general type of interrupt, like RB4 to RB7. We have set these four registers are used in port change interrupts. And I explained about timer in the previous slide, right? So once the timer once the either the 8 bit or 16 bit timer data is filled, then timer overflow takes place. During this timer overflow, an interrupt is created. That is what this timer overflow interrupt is about. So now I have explained about the various concepts of interrupt. So now I'll explain about how our project is going to work. So the main, as I explained about all these things, you might have come to a conclusion that the main component of a project is the microcontroller. So I'll explain what are all the other components which we are using. So first of all, to display the current status of our project, we are using a CLCD, which displays the status of a of the washing machine. Like it displays whether it is on, washing, drying, squeezing. So all these process are explained, or all these process are mentioned in the CLCD part. Then the buzzer. So the working of this buzzer can be seen in the simulation part. And the motor, so again this working of the motor can be seen in the simulation part, where it works when turned on and off, which will be explained for you further by my other friends. So and then the four switches, one to turn on. So as a washing machine, as we plan to work the washing machine, the first step is to turn on it. That's why we are using switch 5. And then at some cases we have to stop, pause the work of the machine. So that in that cases we are using switch 6. And in order to run through, or in order to run through other options menus, we have some 9 to 11 menus. So in order to run through these menus, we have navigation option at switch 4. Then the current status is explained using door status. So that's all from my side, and my friends will explain about it in further.
I'm Shreyas here, pursuing final year at Triple A SSN College of Engineering. So it is the Pixim lab where we are going to simulate the output for the code we wrote. So first we have to load that code, which is in hex format. So I have loaded it, and then we can see we have used clock frequency as 20 megahertz. And then this is the LCD screen, which is 16 cross 4, 16 and 4 here. So it is the fan, and then there's a buzzer which we have kept on. If it's here, it's been off. If it's here, it means on. So it is an LCD. It's LEDs. These are LEDs. So this is the controller that we use, PIC 16F877A. It is a 40-pin controller, and then it has a port A, port B, port C, port D, and port E. So we can see the switches here. So it are connected. These are connected to port B. Switch 1, switch 2, switch 3, switch 4, switch 5, switch 6. So these are the things that we use in the program. And then it is reset button. When we click this, the program restarts again. So okay, none. So then think so we can go into the program. So if I press key 5, then the machine gets on. So if I press key 5, machine was on. So we have 12 programs, each of which can be scrolled on using RB3. So if I use this once, then the program scrolls down. You can see here. So it came to daily again. So when I long press this switch 4, it goes to the water level. So we have 5 water levels, each of which can be scrolled down using the same switch 4 if I press it once. So we can see it auto came again. When I long press this, it goes to the stop screen. When I press this switch, it will start. When I press this switch, it will stop. So I will just click this, and then we can see here the washing machine starts running. It's of 40 seconds actually, and then this fan also is running. You can see. So when I press this switch 6, it actually passes. So when I press this switch 5, it resumes from where I left. So where it left. So this is the switch 1. The thing is, when I press this, the door opens. So we can see the LCD is showing like close the door, and then the fan would have been off, and then buzzer would be on. When we release it, when we actually close the door, the program resumes from where it left. The program is completed and the clothes should be removed. Goes to the washing program screen again, and then if you don't want, we can reset it. So that's it. This internship, we understood the basics of C programming and embedded systems. We gained in-depth knowledge about the PIC16F877A microcontroller and its peripheral interfacing. We actually learned to use MP Lab for code development and also did the simulation with the help of PICSIM Lab. So as a part of this internship, we successfully completed the washing machine project where we applied our knowledge to implement keypad input, LCD display interfacing, timer based content using the PIC microcontroller.